In lesson 6.4, we looked at solving systems of equations using the elimination method, but unlike lesson 6.3, the two equations are written in a way where you cannot eliminate either of the variable terms right off the bat. If you look at both of our equations, the first equation we have x plus 5y equals 17, and the second equation we have negative 4x plus 3y equals 24. Neither the x or the y variable terms cancel out. So, if we run into that situation, we need to cancel out one of them. It doesn't matter. You have a lot of flexibility in solving these problems. But there are some hints or tips to help make the problem easier for you to solve, depending upon the way the question is set up. If you look at both sets of variable terms, you'll notice that the x variable term in the first equation is positive, and in the second equation it's negative. That's one of the keys that you're going to want to look for in order to decide which one would be better to cancel out first. Since we have that situation, I'm going to go ahead and show you what you need to do in order to eliminate the x variable terms from both equations. So in order to eliminate or cancel out the x variable terms, we need the opposite of a negative 4x, which is positive 4x. So in order to keep our equation balanced, I have to multiply every term in the top equation by 4, which is basically using the distributive property. So 4 times x is 4x, 4 times 5y is 20y, and 4 times 17 is 68. And then we can just bring over the bottom equation. Negative 4x plus 3y equals 24. Now we can eliminate the x variable terms because we have variable terms with the same coefficient of opposite sign. So 4x and negative 4x cancel out. 20y plus 3y gives us 23y, and 68 and 24 gives us 92. We can isolate the variable by dividing both sides by 23. And we will find that y is equal to 4. Now, we want to find the value of x. So, again, it doesn't matter if you use the first equation or the second equation, but we simply need to substitute our value for y into either equation and figure out what x equals. So, I'm going to use the first equation, x plus 5y. We found that y is equal to 4 equals 17. I can evaluate 5 times 4, x plus 20 equals 17, and isolate the variable term by subtracting 20 from both sides. X equals negative 3. So, we have a solution of negative 3, 4, and we want to make sure that we're right. So I'll use the bottom equation this time. Negative 4x plus 3y equals 24. Negative 4 times negative 3 plus 3 times 4 equals 24. Let's see if that checks out. Negative 4 times negative 3 is 12. 3 times 4 is 12. And 12 plus 12 is 24. So, your solution checks out. And again, remember, what this means, negative 3 comma 4, is that if you were to graph both equations, they would intersect at point negative 3 comma 4.